The question is question number 66. The correct set of 4 quantum numbers for the valence electron of barium atom. Atomic number is also given. So you just have to choose the correct set of quantum numbers. We know that whenever we talk about barium atom, atomic number is also given. Its electronic configuration is Xenon's configuration and then 6s2. This is the configuration for barium. It means it is alkaline earth metal and the valence configuration is Ns2. Now in this case, if we write the set of the quantum number, for valence electron. Valence electron can be 6s1 electron or 6s2. So it can be represented as n is equals to 6. Further, the L value. With the help of S value, you can find out L value is 0. Now, you want to find out M value. The value of M depends on the value of L. That is equal to minus L2 plus L. So it would be 0 again. And S value can either be plus half or it can be minus half. Now, if it is so, we can easily find out the correct option. Let's see. In the first option, it's not given. N value is 5. In the second option, N value is 6. L value is 0, but the M value is 1. That cannot be possible. Then in third option, 6 is the N value. L value is 1. That cannot be possible because we are talking about 6s orbitals. So this is also wrong. Fourth option is the correct option, that is correctly representing the valence electron. So answer is option 4. Now, after this, question number 67. When a metal is exposed to light of wavelength lambda, photoelectrons with maximum kinetic energy 2 electron volt are ejected from metal surface, the photoelectric effect. Now, on exposing the same metal with light of wavelength lambda by 4, it means wavelength is reduced to 1 by 4. The ejected photoelectron have maximum kinetic energy 10 electron volt. Now, the work function of metal is, we all know that whenever we talk about the energy of incident light is equal to the sum of h nu naught, that is work function, and half mv square, that is kinetic energy. So in this case, we have the first condition. When this h nu can be calculated with the help of hc by lambda, that is hc by lambda, and lambda is the wavelength, that is also given. Lambda is equal to work function, say that is W naught, plus what is kinetic energy, that is given here. Maximum kinetic energy is 2 electron volt. Now this is the first condition. The second condition is hc by lambda. Now the lambda becomes lambda by 4, that's given in the question. So this expression becomes 4 hc by lambda is equal to lambda naught plus, what is the kinetic energy for this case? That's clearly given here. It is 10 electron volt. Initially it was 2 electron volt. Now, so we can write here 10 eV. Now, if you solve this part, if you divide equation 2 by equation 1, you will easily find out that 4 is equal to W naught plus 10 divided by W naught plus 2. And if you solve this for the value of W, you will find out that this 4W naught plus 8 is equal to W naught plus 10, and the value of this W naught is equal to, there would be 2 by 3 electron. This would be the value of W naught. And what is that? That is work function. So the value of work function is 2 by 3 EV. This is the answer for this question. Answer is option 1. I hope this question is clear to you. Let's check what is the next question. Question number 68. Select the electronic transition in hydrogen atom for which no spectral line is observed. So whenever we are talking about hydrogen atom, for hydrogen atom in ground state. Energy of electron doesn't depend on L value. What does it mean? It means if we check the first option, there's a transition from 4p to 3d. In this case, energy must be changed. And if energy is changed, definitely spectral lines would be observed. In the second case, electron is going from 2p to 1s. In that case, n value is changing, energy changes there, and that's why spectral lines would be observed. Then we have 3d to 2p. In this case, n value is also changing, and in that case, there must be the formation of spectral line. Then we have 3p to 3s. If we look at this 3p and 3s orbital of hydrogen atoms are degenerate. What does it mean? They have same energy. So in that case, there is no release of energy and no spectral line would be observed. It means this is the correct answer. That's option 4. After this, the next question. Question number 69. The incorrect statement regarding octet rule is, let's check the statements. It does not account for the shape of the molecules. Yes, if we talk about octet rule, it does not give any idea about the shape of the molecule. That's why this is the correct statement. Then, it does not explain the relative stability of the molecule. Octet rule doesn't talk about relative stability of the molecules. That's why this is also the correct statement. Then we have, it is based upon the chemical inertness of noble gases. As per octet rule, if an atom has 8 electrons in its valence shell, it is considered as stable. And if we talk about noble gases, these are inert because they have stable octet in their valence shell. That's why this statement is correct statement. It is mainly applicable to the elements beyond the third period of the periodic table. This statement is incorrect because octet rule is applicable on the elements of second period also. So, this is the incorrect statement, and if it is the incorrect statement, this is the correct option for this particular question. So, answer for this particular question is option 4. After this, the next question. Now we have the question number 70. The formal charge present on sulfur atom in the given structure is, and basically we are talking about the formal charge that is present on sulfur atom. And in this particular case, we can clearly see that we are talking about sulfur atom. It is covalently bonded with 2 oxygen atoms, while there are coordinate bond between sulfur and oxygen also. Now, for covalent bonds, contribution towards formal charge is 0. But if we talk about the coordinate bond, the formal charge contribution that is +1. Now, just calculate the formal charge on sulfur atom. That would be the formal charge due to 2 covalent bond, that is 0 plus 0, plus the formal charge due to coordinate bond +1, because 1 coordinate bond is there, then further 1 more coordinate bond is there. So the sum of all these is +2. And if it is so, the correct answer is given in option 2. Answer for this particular question is option 2.